There we go. KBS is at 127, so people probably can't even hear me right now. Drop frames, 65%. Good lord. Spectrum Internet, please fix your shit. 600, there we go, 5200. Hello everyone. Welcome back. God damn. Welcome back. Sorry my connection blows. I'm back though. Okay. 0.875 divided by 2 minus 0.1. Okay, 3375. So I need to go over. And now I should be lined up with this guy here and this guy here, which is great if it's correct. So I'm going to take a circle here. Oh wait, actually I'm going to make it a square. Here, and then, okay, just making sure that I'm lined up with these two. Not going to actually make that square. Now, I'm going to move this to half of 0.875, which is 4375. And now, oh my gosh, okay, I'm going to move this to the right, 0.875. And then I'll move it again to the right, or sorry, to the left, 0.55, and we should be right where we need it now. And then I'm going to create another one. Even though it doesn't go anywhere after this, I want to create another one because I want a place for the L wire to go up and then back down again so it can be hidden, whatever's remaining of the L wire. So that should be correct, and they're at the right height. They're at 0.9. So now we just need to create the lines between them. These are right height? Yes, 1.15. Got it. Okay. Get rid of these constraints. Again, we don't need the constraints. And what we're going to do is if we are... Okay, so if these points... Let's find out where the line is. Line between these 2 points is here. Line between these 2 points going the other direction. This height on the Y is 19.625. So this is going to be, this line going down is going to be the outer portion of the inner trench of the bottom trenches, which means that its turn is going to be 0.2, which means you need to stop 0.2 before this. So if this is at 18.9125 and this is at 19.625 minus 18.9125, it needs to go down 0.5125. I would hate this if I wasn't good at math. It would be so fucking difficult to do so much of this. Okay, so that was 0.5125. 0.5125 minus 0.0375. 0.475. Okay, so this needs to go down 0.475, 90 degrees. They should line up. Good, perfect. So I've got 2 of them ready. And now I need to do these lines going around this circle here. So this guy here is the easy one. It's going to be 0.1. And then this guy here is going to be 0.1 above this. This is 18.9. This is 18.8, which means it needs to be 1.1 longer than this, which means it needs to be 0.6125. You can see in the bottom right down here. 0.6125. Now they should line up. Good. Now, this needs to be 0.1 as well. And then it needs to be 0.0375 longer than this. which is 0.65. Get rid of these constraints. They're all lined up. Perfect. Okay. Now, I have already screwed this up. Oh, okay. That's all right, because I can actually, it's a quick fix. You're going to see me do that a lot. Because this is the center point. So if you, it lines up with this hole. So what I'm actually doing is I shouldn't be lining these up with the center. I should be lining these up with the outer walls of the trench. Which means that this, make sure I raise this to the right height. Even though I'm not going to use it, I'm just going to use it to like touch other pieces and do snaps. Okay. So yeah, this is like 0.2 away right now. If I did a square, 0.2. But that's the problem, because this shouldn't be, this actually needs to be 0.05 up to represent the upper wall of the trench that's going this way. So these all need to be moved up as well, where they need to be 0.05 shorter than they are right now. So let's just do that. This needs to be 0.6. This needs to be 0.5625. This needs to be 0.4625. And this needs to be 0.425. Okay. Now, is that correct? No, it's not. Now they should have been going the other way. All right, quick fixes. This is a 0.6, actually needs to be 0.7. They only need 0.05 the other direction than I had them, so 6625. This needs to be 0.5625. And this needs to be 0.525. Okay, so now, if you look at this square, this one right here needs to be 0.1 from it, and you can see it is. It's 0.1 now, so this is correct. So I'm going to create a square that is 0.1 and 0.1 here. Get rid of this entirely. And then create a line here. Doesn't matter how long it is. I'm just going to do 0.1. Then I'm going to get rid of this box here. And I'm going to create the lines that we're going to line up with. So 0.0375, 0.1, and 0.0375. It doesn't matter how long these lines are. They're going to get deleted in a second. I'm just creating them so I have something to fill it to. Fill it being creating these corners. There is a command. There's like a keyboard command for filleting, and I'm supposed to know it, but I don't know it. I know L is line and B is box. But I don't know the one for fillet. It's not F, is it? Hold on, F. No, that's something, but it's not. It says, and this is the fillet menu, but it's not the one that I want. Is it like Control F? Shift F? No. Don't know what it is. Okay, that's fine. Okay, so now I can delete these lines. And now, if you go to the top, you can kind of see that these line up with where this needs to be. So we're going to find the x here, which is 4, super convenient. And this 56625. So we know the length that we need to get to here is 1.6625. So let's line it up, 1.6625. And now if I top, boom, lines up right with the trench. Perfect. Okay, so we're going to do the same thing here. And this is going to be 1.525 because it's going to go, oh, it's 5.625. Okay, hold on. 1.565. And then I'm going to do the same thing here, except it's going to be 1.5625 minus 375. So let's top that real quick. And that is correct. If you made a box between these, it'd be 0.375. Perfect. Okay. So the only constraints I like are these circular constraints, because I like knowing the width of my circle without having to click it and go down to the diameter. Just to make sure that I can that's why you see them in all of the, you see them here. This is actually 2 different constraints. It's 0.525 and 0.65, which is the inner circle and outer circle that make these tubes. Okay, so there's one more, which I need to take this length, 1.6625, and add 0.0375, which is 1.7. The distance here, 1.7. And then this needs to be 0.0375 plus 0.1 plus 0.1 plus 0.0375, which is 0.275. Math. And then it's over here, it needs to be the same thing minus 0.1, so it's 1.7 or 0.175. And then if I top, this will go slightly past, and then I need to connect these two. Oh gosh, okay. So now, get rid of some of these constraints, which again, I hate that it auto creates those. You can't get rid of that feature for some reason. As far as I know, this needs to go 0.1, then this needs to go 0.1, then this needs to go 0.2. Okay. So if I top that, boom, we now have a trench that goes all through here. And it stops here because I have a line here. Yes, get rid of that. And a line here. Get rid of that. And hold on. How do I select the circle? Okay. Let's do it this way. It still works, right? It's okay. Yes, okay. So we're gonna top. Get rid of this line here. Then, boom. We have a selection of the entire trench. Perfect. And that should be all that I need, because that's where it stops, right there. This. Perfect. Okay. So, we have the bottom trench now. We have both bottom trenches. This one here just kind of ends, whereas this one is fully surrounded by this right here. It's all in 3 pieces because it, like I said, it doesn't connect here, so it doesn't go all the way around. It doesn't connect to these parts, so it's not all one big square around. It ends at the part that when the square ends. I know what I'm saying doesn't sound like it makes any sense. I promise it all makes sense in here. Okay, so now I'm going to try selecting it all and doing a fix. And now I'm going to select the circles and do a fix. They are also ready to be affixed to a position. And fix. Okay, so now we are ready for the next step. Let's look at the pacNR data thing here. model extrusion. So we have a base square, which is just the whole bottom piece. We're just going to make a big... The way the 3D models work with extrusion is that you basically just say, hey, take this object and expand out from that position into like a 3D model space. And then you can also say expand that area but cut anything you hit instead of joining it to the current model. So we make a big square, then we start cutting into it. We make it like a rectangular prism. We just start cutting into it. And that's how we build what I have here. So we have the base square, we have the middle square, we have the... Oh, connector rods. Of course. Okay. So this piece above it has connector rods, which means this needs sockets. But then on the right, we're going to need rods to go into the middle bottoms sockets, which it exists. It's just you have to here, show it like this. Boom, it's here. So this is going to have sockets. This is going to have rods. And then this has rods. This needs sockets. Again, I know it doesn't make a lot of sense, but it's okay. It's all in here. It all makes sense in here. Sometimes people will contact me and they're asking about like usually my first PAC-MAN project, and they're like, yo man, how did you do that? And it's like, man, if I thought for 1 second I could properly explain it, you don't know how fast I would explain it, but I don't know how to do that. I don't know. I know what I did, but it doesn't really translate to words sometimes. 0.1 and 1.945. Explaining why I'm doing this would even take a long time. It'd be so hard to explain it. Okay, 0.11 and 0.3. Oh, nope, that's wrong. 0.3, 0.11. Okay. Like, explaining what I just did would be difficult. It would be very difficult to do that and properly, like, put together why I just made that little 1.945 length of rod line. God, it's so hard to explain this project. I don't want to delete those. I just want to delete the line. I just hate this line right here. Hold on. Is this... Oh, okay, you can see it like flashing. I'm just trying to create... Oh, God. Okay, let me just undo all this shit and do it a different way. I'm going to create a line here, 0.1. No, 0.3. Then I'm going to create another line from this direction, 1.945. Okay, so if I want to create a socket where the center of the socket is 2 inches from the side and the socket width is 0.11, then I have to create a line that is 1.945. That is the distance to the first side of the socket. I know that all seems like a lot, but if you look at it here, and I say 0.11 and 0.3, now I can delete these two lines easily. And what I have is a little socket I can create where the center point, if you look here, it like locks and creates a little triangle, is 0.2 from the end. So this is now ready to go. I'm going to fix this and create the next one. Okay, I'm going to do the same thing over here. 0.3, line from there, 1.945, and then create a square from there that is 0.1 and 0.3, and delete these lines. Okay, get rid of the constraint. It is now oh, shit. Undo. Okay, sorry, I made it 0.1 width instead of 0.11. It needs to be 0.11 because the rod is 0.1 and PLA, the plastic I'm using, expands slightly, which means that I need to like make the hole slightly larger than the rod it slides into. God, it's all so confusing. It would take me days to explain this project to somebody. Multiple days. Okay, so now it's 0.11. If you do the square trick again, you can see that it's 0.2 from the edge in the center of that rod, which is exactly what we want. So we're going to fix it. Then over here, we're going to do something similar. 0.3. Oh, hold on. Okay, so what you may have seen there is that the angle, you see the angle that's near my mouse, is like 12 degrees, right? I had it here. That's not 0 degrees. I want it 0 degrees. because otherwise the end of the point will not be correct in the right spot. It'll be just slightly off, like a number rounding error off, and you don't want that. So now it's 1.95. The reason it's not 1.945 like the other is that these rods, like I said, are not 0.11 width, they're 0.1 width. Which means the halfway point is 1.95 to the wall to create the halfway point at 2. Which again, I know all of this is a lot. But now you can see it is 2 inches from the top. Perfect. And it is 0.1 width. So I'm going to fix that. Create one more rod. Now I've learned all these little tactics through a lot of mistakes and a lot of very expensive time-wise mistakes. And sometimes money-wise, because I had to buy all the PLA too. So it seems like manic. It's just because, it is. Yeah, I made so many mistakes that I'm like running out of time now on my project. So, 0.2 or 2 inches, fix it, and we're good. Okay. So now, if you look at the data, we have the connector rods, we have LED port tubes, wire pathways are next. Okay. So, I have this right here, which is the light order layout. If you look at this, it's 8 lights wide and 1, 2, 3, 4, 5, 6, 7 high. So I'm going to go and I'm going to highlight that. 4, 5, 6, 7, 8. 4, 5, 6, 7. Boom. This is 7 high and 8 wide. What you're going to notice here, we may not understand what this thing is. This is the order the lights. The lights are in a string. So I needed to decide how the lights were going to move from piece to piece, where they're going to start, where they're going to end, where the power is going to be connected in. So they start near the center, and they loop around. And what I attempted to do is create a pattern that would not have me jumping from piece to piece a lot, and have basically like try to fill a whole piece of the 9 pieces and then go to the next one. But that's nearly impossible because the lights have only a certain distance between them, so unless I want to cut them and resolder them with longer wires, I sometimes had to compromise. So I now have to figure out where the wire is going to go between one to the next and create a pathway that will go between them. So if you look at, for example, let me finish the sketch. Let me look at middle left. You see this hole right here? That's because there's a wire that's going to go. This light has a wire under it that's going to go to the next piece over here. So I need to make a pathway here as well to go between the two. If you look at like middle, for example, there's wire pathways here and here, and they line up with the wire pathways on the middle so that the wire can just go between them easily and have the space and not have to cut and resolder or like, drill a hole between the two because I forgot to do that. So I'm just making them early and doing that. So we're going to make the sketch. We're going to go bottom left. These are fortunately really easy to make. I just go here, I hit line, I walk it over without clicking, and it keeps me in line with the center, which is really nice. It locks me there. Go all the way to the edge here. This X represents the point on this axis, on the Y, where it matches the outside. So I can just click right here and start a line, go down to here. And then I start from there and go back up to here to line between the two wall pieces and delete the first one. And I suddenly have a line. I do the same thing on the other side. And boom, I now have an area I can extrude out and cut to get a wire pathway. Easy peasy. So let's see where all the wire pathways are. So we have one right there from 172 to 173. And then here I've okay, so like if you look, it's like 175, 6, 7, 8, 9, 10, or 80. 1, 2, 3, 4, 5, 6. It jumps, oh wait, sorry. It jumps 2 over to here, 7, 8, then turns around. Like I said, I made this pattern to lower the amount of pathway jumps between pieces as many as possible, as few as possible. So it goes this way to 180, jumps over here to 191, 192, 3, 4, 5, turns around again, 6, 7, 8, 9, 200, 201, and then here. So this connector here is the only other piece I need to make a pathway between them. And if you look at bottom middle, if I finish sketch, I haven't extruded out bottom middle, but I'm also going to need to make a pathway here. So I'm going to make one here and here. Let me just confirm that again one more time. Yes, okay. So 201 to 202 is going to be the only one I need to worry about other than 172 to 173. Easy peasy. So I'm going to do the same thing here. And boom. Okay, so now I gotta move to the extrusions. I don't know if my uptime is gonna know how long I've been streaming because I got disconnected. So let's see. Uptime 26. Yeah, it doesn't know. But I believe I started at 8:30, so we were at an hour and a half. Sorry to everyone who lost connection at some point. Hey, I've arrived. Why was that partially transparent? Hold on, let me show that again real quick. Show off my bear. Test. Oh no, the show off your bear thing doesn't work anymore. Alright, I'll figure that out. God damn. Oh no, there it is. Yeah, sorry, I'm on a delay. I didn't realize how partially transparent that is. I gotta fix that up. I know I did that on purpose, I just don't remember why. The bear shouldn't be transparent, just the background card should be transparent. That's the fix for another day. I have so many dumb little projects, I don't need to worry about that right now. Okay, so we're going to do the extrusions, I think. Have the connector sockets, have wire pathways, top trenches, bottom trench retainer, bottom trench, L wire through holes, screw insert holes. Oh yeah, screw insert holes. Hold on. Let's finish the sketch. Excuse me. This is at x0. You can see here it's like negative 4.604 e to the negative 9th. It's at 0. It's just not properly rounded to 0. So we're going to do... Where is my bottom right? Where is all of bottom right? Hold on. Did I lose it? No! I'm printing it right now. I know I made it. That's terrible. I have no idea where it is. Middle right? Finish sketch? Where did it go? Did I delete? I'll find an older version of it and I'll just grab it and grab it. I already have the STL. I don't want to have to rebuild the model. No, this piece here is done. I just don't know where it is. I don't know how it got deleted, but I'll be able to recover it. It's fine. Okay, so I need the screw holes. So this height here is at 9, and this height here is at 17. So I take the screw holes and copy them, and then do bottom left, paste them. I should be able to move them down 8. We should be almost at the right position. You can see the top ones are at the right position. The bottom ones are not. That's because this length is 6.7875 and this length here is 7, which is a difference of 0.2125. So these both need to be moved up 0.2125. Now they're in the right position. Okay. I'm going to fix those as well. And that's just an easy thing. Since I've already done it, that's super easy to just do real quick. We're done. Now I think I have everything I need to start extruding. So I'm going to finish the sketch. I'm going to go to the front view. I'm going to grab everything on the bottom. Then I'm going to go to, it's like, oh shit. Okay, hold on. Undo that. Click out of that. It's like doing all the selection right now. Get rid of everything other than bottom left. Now grab it. Okay. I'm going to jump to the bottom. And I'm going to deselect the things I don't need. So if you look at the extrusion, I have even I've written down everything. So like the base square plus outer circles minus inner circles. That's referring to these tubes. So I don't need the inner circles. I deselect these because these are going to be empty space. There's nothing that gets printed there. Almost done. Okay. So look, that's everything I need. And I'm going to deselect these rods because these are not I don't need those. Everything else, extrude. And we're going to extrude it 1.5 inches, which is just the size we're going with these. I'm going to rename this to bottom left. It's so weird that even I must have deleted the sketch of the bottom right. I can grab it. It's not a big problem. Like I'm freaking out over nothing. But it's weird that it got deleted. Okay. So next, I'm going to grab this box here. This is the middle box. And I'm going to extrude that to, I think it's 1.275. Hold on, let me check. Yeah, 1.275. I'm going to cut. And we got that. Okay. So now if you look at it, we're already pretty far through it. This is good. We've got the inside of the box hollowed out. Okay, next extrusion is the connector rods. Okay, so they go up 0.75 from the bottom. They don't go up all the way because if they did, sometimes they would actually like overlap. Like if there was one of the LED circles right here on the next piece, the rod would go into it. So I actually have them only go up half, and the rods start at the half, so they don't overlap, which is great. So we're going to extrude these to 0.75 with a join. Boom. And then next one, LED port tubes plus wire pathways plus connector sockets. So I need to get all of the LED tubes. A bunch of them. There's so many of these. There's 256 for the entire project. So each of the 9 blocks has about 30 of them. And it takes a little while to select them all. So just bear with me, guys. Okay. Is that everything? Nope, wait. There's one more. Okay. Those are all the holes. And then I need to do the oh, it's upside down. So yeah, it's down here. Okay. That, and then the connector sockets. And we're going to extrude all of these to 0.75. Okay, so now, if you look, the holes are a lot shorter. There's a piece right here. There's a socket for these other rods to line up with from the other pieces. And it's looking pretty good. Top trenches. Okay, this one's easy. This is my favorite one because it's super easy. You grab these, grab all the top trenches. Let that be visible again. Perfect. Okay, so we're going to extrude those to 0.125. Cuts in, and boom, the top now has the top trenches. Now the bottom trench retainer, that's the walls on the outside of the bottom trenches. So we're going to select all the bottom trenches. Then deselect the center. And then you have all the walls of it. We're going to do those to 125. Make sure that the thing is visible. Make sure it's a join. The reason it's a cut is because it detects that there's an overlapping section. It's colliding with something. But what it's colliding with is some of these rods. Some of these LED port tubes. And the thing is, you want to join to those sections. You don't want to cut. So we're going to change this to a join. As you can see, now I have this like trench that will be created here. So we're going to join that. Now, grab that center point, and we're going to make sure it might not even detect that they line up or touch in any way. We're going to do this to 125 and cut. And that'll make sure that there's holes through the walls. So as you can see, what that just did is it created a hole here and here, so that we can push wires through between the two blocks, pieces of the 9 pieces. Okay, so top here. Next, L-wire through holes, and then screw insert holes at, let me do, hang on, 0.50625. I'm going to copy that so we can just do that easily. So let's start off and do the screw holes. That's these guys here. And make sure, yep, perfect. We're going to extrude to 0.8. That cuts through. So now you have these holes from bottom trench to top trench in the areas that the trenches line up with. And then we're going to grab these guys down here. These are the screw holes. We're going to extrude distance of 0.50625. Those cut in, and then you have holes here that are where the screw inserts go to connect the top and bottom pieces to like lock the whole thing together. Again, this is all a process that generated through a lot of mistakes. So now what we have is, I think we have the whole piece. I think it's done. I think it's ready to export. So I'm going to save this. I'm going to export out pacNR v3 bottom left STL, and we're good. Let's have a quick look at it's another ad there, at BlueStacks. We're going to look at the the camera feed of the 3D print of the bottom right piece, because it's printing right now, which means I've done it. I just somehow lost the sketch in here, which is upsetting because I know it's somewhere and I have to like load an old version to find it. I'll figure it out. But for now, I have the bottom left, which means I can now go into the remote desktop connection and drop that on the desktop here. Well, middle right goes here, middle left goes there, bottom right goes there, bottom left goes here. Okay, so I just don't have middle yet, which I have to like figure out how I want to do. So the whole thing is controlled with an NES controller. So before, the idea was like, oh, I have to find a spot inside the 3D printed thing to like slide the controller when I'm not using it, and then it just plugs in there, and I can just open it up and pull the controller out. But that proved rather difficult to figure out. So instead, I'm going to just have a port that this plugs into, and then this will just be external to the whole thing, which is, you know, not ideal, but it's a lot faster of a process for me to do it that way. And I need to finish this before Burning Man, so yeah. So let's check our camera. It's looking good. It's looking very good. That is the bottom right piece, and I just finished the bottom left piece. The bottom middle is the only one that I still need to finish. Actually, that's technically not true. There are a couple pieces I need to finish, because if you look at the Middle. Where is middle right? What happened to this? Okay. The middle right has a body somewhere. I don't know where it is, but we have a body for it. If I have to re-extrude it, and I'll do that. But it has this hole. Oh, actually, let me show you. There we go. Okay. So the battery for this whole project looks like this. It's like 2 inches by 4 inches. It's a little USB power bank. It has all the power it needs to run this thing. But the problem with it is I don't want to be carrying this around and then pulling out a little wire on the whole thing and then plugging it in. And it just looks unprofessional. I'm already doing that with the controller, as I just explained. I don't want to do that with the battery. So, on the right side, do I have the imager still up? No, I don't. On the right side of the board of PAC-MAN, I wonder if I have like, I'm just going to pull up the imager real quick. Hold on. It'd be a lot easier to explain if I have the picture available for you guys. This one will do. Okay. So as you can see right here, there's space on the side where it's like 3 lights by 4 lights of a big square that isn't used by anything in the project. That's enough space for this to fit, just barely. So, as you can see, that exists right here. There's 4 across, 3 down, that's this position. I'm going to put the block, I'm going to put this here, in here. But it's going to be on the other side, it's going to be right here. So what I did is I created this little indent, and I'm going to 3D print a box that then gets super glued into that indent, and then I'm going to do a little slider piece door that slides down here and locks it closed. Once that thing is super glued in, this will be the removable piece, and I'll be able to pull this up, pull the battery out, connect it, push it back in with some cloth or something to hold it still, close it. The whole thing is just going to be self-contained. I'm very happy with this idea, but what I'd really like is a really tiny version of this. I want one of these that is like half the size, so that I can do the same thing on the opposite side of this project. I would love that. Maybe I'll try to search one of those, but I'll probably only find USB ones, which is not useful to me because I can't interface with USB from an Arduino. So I need one that uses the same connector thing as the original Nintendo controller. God, this is so much I have to learn to get this project to work. So anyway, that's what I'm dealing with right now. But we have finished the bottom left piece, which I'm super excited about. And I think that's almost 2 hours, and no one's really here, so I think I'm going to end a little early. I'm sorry for the disconnect in the middle of the stream, and I'm sorry if this was all very confusing and potentially very boring, but I am finished with it. And I probably won't do another 3D modeling stream because by the time I stream again, I will be done the last piece. The only piece I need to do is the bottom middle, and then all the back plates, which really take like a minute each and would be very repetitive and boring to watch me do. And then the main thing I have to do after that is I have to 3D print all of it, which this piece, let me just explain to this piece does not look very complicated. I build it upside down, so I build it this side up, which means it doesn't need to fill in this area with like support that I have to rip out then. Basically, and also it means that this side here is very nice and flat and smooth because it's on the bed, so it melts very nice. That saves me a lot of time, but this piece still takes like 26 hours to print because 3D printers are very slow because of the laws of physics and the limitations of doing a 3D print at the speed that I'm doing, which I do to make sure that it's very nice and smooth and clean when it's done. But yeah, with that said, the 3D printing takes the longest. And so the current print is going to take another 25 hours because I just started it before the stream because the last one screwed up. And sometimes that happens. Sometimes I'll be like 15 hours into a print and it'll just screw up. And sometimes I don't realize until I'm like 25 hours into a print. I just have to start the whole thing over, which is why I have a pile of mistakes and errors and screw-ups. And I'm hoping that pile does not grow any larger than that. I would love if it just stayed right that size and I didn't screw up anymore. If I don't screw up, this whole project, all the 3D printed parts at least, will be done in about a week. A little over a week. Which gives me plenty of time to work out all the bugs, 3D print 1 or 2 more pieces if I need to replace something from some small mistake, 3D model anything that I needed to, that I made a mistake on, test it out, make sure everything's really nice and sealed, build a little handle for it, like everything I need to do to get this project done. I should have enough time. If I finish it, I will show you guys on stream, I promise. Also, if it works really well, I'll probably release the plans on Thingiverse and make an instruction video on how to do the programming and wiring. I will not be doing an instruction video on 3D modeling it because, like I explained, goddamn, it is difficult to explain that project to anybody. It is difficult. I can't even explain it well to myself if I had to put it to words. There are so many little things I learned, and it's all tribal knowledge inside this head, and it's just going to be gone when this project's over. And I'm okay with that. This is the final version of the project. I don't need to save the information for later. If I keep 3D modeling after this, though, I guess I'll probably eventually write the stuff down, because there's just a lot that is useful to remember when you're 3D modeling. And it's weird because you'd think it'd all be very straightforward, but it's not at all. There's just so many little tricks. To all my 3D modeling friends, good for you, man. That's difficult shit. Anyway, I'm going to end here. I'm talking to myself, so I'm just going to end here. Thank you guys all for coming, for the ones who were here earlier. If someone's, I think the person watching now is just me. Maybe it's Foxy. I will see you guys next time. I'll see you on Saturday. It's been good. I'm not going to raid anybody. You are here. Hello. Not going to raid anybody, but because it's just you. But thank you for coming, and I will see you next time on Saturday.